Hey everyone! In this video, we will learn what is a data type, a brief introduction to different kinds of data types in Golang, and why do we actually need them in the first place. So, a data type is a classification made on the kind of data. They categorize a set of related values, describe the operations that can be done on them. For example, we have string, which is a sequence of characters and is used to represent text. Then we have numbers, which consist of integers and floats. So, integers in Golang are like integers in mathematics. They are numbers, but without any decimal counterparts, such as -10, 0, 112, and so on. While float, on the other hand, are numbers that contain a decimal counterpart, such as 7.0 or 89.05. Next up, we have Boolean. So Boolean consists of just two values, true and false. Then we have arrays and slices. So an array is like a list or a sequence of elements of a single data type. So we can have an array of just integer or just strings or just floats. While slices represent a flexible array-like data type, but they also provide more control over memory allocation. Next comes map. So a map is a collection of key value pairs. For example, we can have a map of string to integer. So the key x over here refers to the integer value 30, or even a map of integer to integer. So don't worry, we'll study about all of these data types in detail later on. For now, let's address the question. Why are data types needed? So first of all, they categorize a set of related values, just like how we saw. Second, they describe the operations that can be done on them. And let's see what this means. So if a data type is a number, for example, it's often possible to perform mathematical operations on it, such as addition, multiplication, and subtraction. While if it's a string, we can perform operations on it, such as converting it to uppercase, or even calculating the string's length, which we cannot do if it's an integer. So programming languages extend different kinds of functionalities to different kinds of data types. And now the most important point, that they define the way the data is stored in the memory. Let us understand this with a few examples. So whenever we say that we want to store some data in a code, a certain memory is allocated for it. This process is known as memory allocation, that is setting aside sections of memory to store some data. For example, when you say you need to store data of integer type, 4 bytes or 8 bytes of memory is allocated to it, depending on the kind of machine. While if the data type is a Boolean, just 1 byte is allocated for it. Hence, we need data types to get the information for memory allocation. Now let's learn what kind of a language Go actually is. But before that, it's important to know the difference between static and dynamic typed languages. So languages are said to be static typed or strongly typed if compiler throws an error when we use data types incorrectly. Some examples of such languages are C, C++, and Java. Let's understand with a simple C++ example here. And don't worry, you don't have to understand the code. We'll just focus on the code logic. So here we have a function called add, and it takes in two inputs, int a and int b, which are supposed to be two numbers, and it prints out the addition result a plus b. So here when we give two numbers as an input, which is as expected, it will print the addition result. While if we try to give one number and one string, it will throw us an error because that is not what was expected by the compiler. And this is the reason that it's throwing us an error. So C++ is a strongly typed language, and hence compiler will throw an error when we use data types incorrectly. Now languages are said to be dynamically typed or sometimes also loosely typed if the compiler does not enforce the data type system. Some example of these languages are Python and JavaScript. For instance, let's understand from the same example, but this time written in JS. So as you might notice, we don't need to write int a and int b over here. We can simply write a comma b. So no need of specifying the data types. Now here, when we give two numbers as an input, it prints out the addition result, which is fine. It worked in both the cases. Well, if we try to give one number and one string, function still adds both of them together and gives us the result. So in this case, compiler did not enforce any data type system. And the such languages are called weakly typed, loosely typed, or dynamic typed. Now, both of these kind of languages have advantages of their own. And before we know what kind of a language Go is, we need to also know the advantages of both of these kind of languages. So for static typed, it provides better performance. Bugs can often be caught by a compiler quickly, and it offers better data integrity. While for dynamic typed, it's faster to write code, it's generally less rigid to work with, and developers comparatively feel that they have a shorter learning curve when they are using a dynamic typed language. So, what about Golang? Talking about Go, Go has a concept of data types that is either explicitly declared by a programmer or is implicitly inferred by the compiler. So it's a fast, statically typed, compiled language, but sometimes it's so easy to use that it feels like a dynamically typed, interpreted language. Now let's see a program in Golang to kind of get an idea of what does this mean. So first we have package and import declarations. We've already learned about them in the previous modules. So now we would be writing our code inside the main function, which is basically the entry point of the program. Here we declare a variable called name, and this is a very popular way of declaring variables in Golang and is known as short variable declaration. Now you might have noticed that we didn't specify any keyword or even the data types of the variable. This is because the compiler has implicitly assigned the string data type to the name variable over here. Now we print it, and when we run a program, we get our expected result. So no worries if you did not understand the program completely. We'll get into the details of variables and declarations later on. So previously we studied what is a data type. Now let's study about various data types in Golang. And in this section, we would be studying about numbers, string, and booleans. So we can split numbers in Go into two different kinds, integer and floating point numbers. So integers can be defined in Golang using many keywords, but the most used is simply int. So int over here refers to signed integers, which means negative and positive numbers both. So some examples could be minus 90, a million, 200, 453, and so on. So Golang gives us a lot of options to define integers based on the size of memory they will be allocated. So we have int 8, which will take up 8 bits or 1 byte of memory, while we have uint 16, which will take up 16 bits or 2 bytes of memory. Also to note here that uint means unsigned integer, which means they'll contain only positive numbers, including 0, while int means signed integer. So they'll contain both the negative as well as positive numbers. Next up, we have float. So float, or also known as floating point numbers, are the numbers that contain a decimal counterpart. And they are either of 32-bit or 64-bit in Golang. But for most modern CPUs, float 64 is recommended. So examples of floats are 80.09 or 0.775, 50.76, and so on. So Go has two floating point types, float 32 and float 64. They're also referred to as single precision and double precision respectively. Then comes up string. So string is any sequence of characters, and the characters can be numbers, letters, and symbols. They are defined in Golang using the keyword string, and the expression is always surrounded by quotes or inverted commas. These all are some valid examples of what a string can be. Also, a string occupies 16 bytes of memory in Golang. Next, we have booleans. So booleans are defined in Golang using the keyword bool, and they consist of just two values, true and false, both in small case letters. So in Golang, they should be just true and false and nothing else. Although some other languages permit the values such as 1 and 0 to represent true and false, but Go does not. Also, a Boolean in Golang occupies 1 byte of memory. We also have arrays, slices, and maps, but more on these later on. So previously, we learned about different kinds of data types in Golang. And in this video, we would be learning how to store that data in variables. So variable is a named unit of data that is assigned a value. It is simply a reference to a value and is one of the foundations of being able to construct programming logic. Now, even if you change the value of the variable, the name of the variable still remains same. In Golang, declaring a variable can be achieved in a number of ways. We've already learned how Go is a statically typed language. And as such, when variables are declared, they're either explicitly or implicitly assigned a data type. Let's understand what that means. So one of the ways by which you can declare a variable in Golang is using this syntax. So a variable is initialized by using the var keyword. Keywords are predefined, reserved words used in programming that have special meaning to the compiler. Over here, var keyword is used to declare a variable. Then we specify the variable name. Then, the data type of the variable. Following it is the assignment operator, which we also call equal to. It signifies that the variable should be assigned a value of whatever is to the right of equals to. And then we have the value or data that we want to store. Let us see how can we declare variables of different data types. Let's start with string variable. So over here, following the syntax that we just learned, so we have the var keyword, the name of the variable, data type, which is string in our case, equals to hello world. So hello world will be stored in the variable s, and s is a variable of string data type. Let's create an integer variable. Again, you use the var keyword. The name of the variable will be I in this case. Int is the keyword for integers, equals to 100. So the variable I will store the value 100 and I is of integer data type. Let's create a variable of Boolean data type. So we have var b bool equals to false. This means that our variable b contains the value false. And as you might remember, that bool data type can only store either true or false value, both of them in complete lower cases. Let's create a float variable. So float variable, you can either use float 32 or float 64 as data type. So we write var f float 64 equals to 77.90. Let's see a running example now. So we start with a package and import declarations. We are also going to start with function main. So we place the variable declaration inside our main function. And in this case, the name of the variable is greeting and it's storing the value hello world. Now we're going to print this variable using the println method by fmt package. So when you run the program, you get the value hello world in the output. This is because the value of the variable was printed by the println method. The value of the variable greeting was hello world, and hence we got hello world in the output. Now, before we learn more about variables, let's see a few methods of how we can print variables in Golang. We've already learned how we can print strings in Golang using the println function of the fmt package. Let's see how we can print strings and multiple variables together. Starting with printing a string. So we'll be declaring our package main and the function main. Now, to print a string, we'll be using the print method of the fmt package. So to use it, we first need to import the fmt package. Now, we're going to simply write fmt.print and we're going to pass the string that we want to print. So in this case, we want to print hello world. When we run the program, we get our output. Let's see how we can print a variable using the same method by fmt package. That's fmt.print. So we'll simply declare and initialize a variable first. In this case, the name of the variable is city and it's initialized with the value Kolkata. So to print it, we simply pass the name of the variable to print method. If you run the program, you'll see the value of the variable being printed in the output. Let's see how we can print variable and string together. So to start with, we're going to declare and initialize two variables, name and user. Now to print them together, we are going to write a print statement using fmt.print method. So first, we have a string called welcome to. Then we have a comma to add more to the string. Now we have added a name variable, again a comma, again a string. This string consists of comma and white space, again a comma to add more, and then finally a user variable. Let's see what we get when we run this program. So on running the program, we get an entire string. Welcome to KodeKloud Harry. Now the only problem with using print method is that it does not introduce a new line after printing. So if we declare two variables and print them one after the other, on running the program, we see that both of them are printed just next to each other. So a solution to this problem is the new line character. So the new line character, or backspace n, is used to create a new line and is placed within string expressions. So when inserted in a string, all the characters after the new line character are added to a new line. So we can say that essentially the occurrence of new line character indicates that the line has ended here and the remaining characters would be displayed in a new line. Let's use this in an example. So back to our example, we declare our two variables, and while printing them, we add the new line character after the name variable to basically introduce a new line between them. And when we run the program, we see that the string Harry was printed on a new line. One thing to note is how a string expression that consisted of backspace n did not actually print backspace n because it was interpreted as the new line character. However, we have another method in fmt package that makes the printing of new line process even more easier for us. It's called println. So now when you use println instead of print, we get this result. So if we simply use println instead of print, it's going to print the input and then it's going to introduce a new line. So notice how it didn't even use any new line character, but the second print statement still got printed on the new line. Now, as you may have noticed, that making up a statement using commas can be quite cumbersome. To our rescue, fmt package has a function called printf function that implements formatted input-output. Now, what is string formatting? So it is the process of inserting a custom string or variable in a predefined text. In Golang, we can use the printf function from fmt package to achieve this. So the function takes a template string that contains the text that needs to be formatted, plus some format specifiers that tell the fmt functions how to format the string, and the object arguments, which are the ones that you need to print in the output. So let's see some examples now. Before that, let's understand what are format specifiers. So format specifiers tell Golang how to format different kinds of data types. Let's learn about some of the most commonly used one. First one is simply v. v is used to format the value in a default format. Also note that format specifiers are always preceded by a percentage sign to specify that it's a format specifier and not just another character in the string expression. So let's use %v in an example. So we're going to simply declare and initialize a string, and then we're going to print the value of the string within a statement. Notice how we have used %v here. This gives us the result. Nice to see you here at KodeKloud. So the name variable over here has replaced the %v in our format string. Let's see one more example. So over here we have the D format specifier. This is used to format decimal integers. Let's see an example again. So we're going to create a variable called grades, and we are going to use the printf method to print a string. When we run it, we get an output as such. So in this case, the grades variable has replaced the %d format specifier in a string, and hence we get our output. Now let us use these format specifiers together. So we declare a string variable and an integer variable. And in a print statement here, the value of the name variable will replace the %v format specifier. And the value of the I variable will replace the %d format specifier. Notice how it's going to happen just in the order they are written in. So when we run the program, we get the statement that we want. So we get, hey Joe, you have scored 78 by 100 in physics. Now here are a few more commonly used format specifiers that we use in Golang. So we have %v, that's used to print the value in its default format. Capital T, it's used to print the data type of the value. D is used for integers. C is used for characters. Q is used to print a string in quotes. Then we have T, which is used to print a Boolean value, either true or false. And then we have F, which is used to print floating point numbers. So in Golang, we can declare a variable in many ways. Let's learn about them. So we've already learned about variable declaration in a standard way. That is declaring and assigning it the value on the same line. One thing to note here is that it's equally valid to declare a variable and then assign its value later. So if you print this variable here on running the program, we'll get the value of the variable as expected. Also note that the data type of a variable is as important as it defines what values may be assigned to it. So a variable with the type of string, for example, cannot be assigned an integer value. If an incorrect value is assigned to a variable, the compiler will throw an error, such as this. We get the error that we cannot use 123 as type string in assignment. There's also a shorthand way of declaring variables. Well, Golang supports several shorthand ways. So variables of the same type can be declared and even assigned values on the same line, such as this. Let's see what we get when we print these variables. So we see that the S variable got the value foo and the T variable got the value bar. So this shorthand version is going to work when the variables are of the same data type. While if the variables are of different data types, we can declare them like this. So the variables over here are wrapped inside the parentheses after the var keyword, but they are on different lines. So if you're going to print them, we'll see our expected results. In addition to the previous shorthand methods, we have one more shorthand version, and it's known as short variable declaration. So it starts with a variable name. So the variable name in this case is S. Then we have := This is short variable assignment operator. It indicates that the short variable declaration is being used. This means that there's no need to use the var keyword or declare the variable data type. It also means that the value to the right of this operator should be assigned to the variable. Then we have the hello world string literal, which will be assigned to S. So this makes Go feel like a dynamic typed language. However, implicitly, compiler has assigned S the data type of string. So here we have successfully declared and initialized a string variable. Let's see an example. So here we are going to declare a variable called name, and we're going to give it the value Lisa. Then we're going to change its value to Peter, and it's going to work just fine. So if you run the program, we're going to get Peter in the output. because name was implicitly given the string data type. Hence, we can later change on its value to another string, and it would work just fine. Now, even though in short variable declaration, we do not explicitly mention the data type of the variable, so if you try to modify its value to an integer, let's say, and when we run it, we're going to get an error. And it again says that you cannot use 12, which is an integer data type, as type string in assignment. So even during short variable declaration, data type is important, and we need to make sure that we are not modifying its value to a data type that it does not support. Let us study about variable scope now. So the scope of a variable can be defined as a part of the program where a particular variable is accessible or from where it can be referenced. So in Golang, scope is defined using block. A block is defined in Go as a possibly empty sequence of declarations and statements within matching brace brackets or curly brackets. So we can say it simply that brace brackets in Go denote a block, and brace brackets within brace brackets denote a new block, which we can call an inner block. The thing to note here about blocks is that inner blocks can access variables that are declared within outer blocks, but outer blocks cannot access variables that are declared within inner blocks. Let's see an example. So we'll start with creating a main function that will act as our outer block. And in this main function, we have created a variable called city and assigned it a value. Now we create another block by simply introducing new pair of brace brackets. And we're going to create a variable called country. And now over here, we have written two print statements to print out country and city variables. Simply for our outer block, we are going to again print both of the variables. Let's see what happens when we try to run the program. We get this error that's undefined country. As you might remember, we just learned that an outer block cannot access variables that are declared within an inner block. And over here, country is a variable that's declared within our inner block. So if we remove this line, a program is going to just work fine. Now we've understood how variable scope works in terms of blocks. However, scope rules can also be determined based on where the variables are declared. We have two kinds of such variables, local and global variables. Talking about local variables, they are variables that are declared inside a function or a block and are termed as local variables. These are not accessible outside the function or block. And these variables can also be declared inside looping or conditional statements. Let's see an example of a local variable. So over here, we have our main function. And inside this main function, we're going to simply create a variable called name. Over here, this name variable is a local variable since it's created inside a function. That's the main function. Now, what are global variables? So global variables are variables that are declared outside of a function or block. They are available throughout the lifetime of a program. They're declared at the top of the program, outside all function or blocks, and well, they can be accessed from any part of the program. So let's see how can we create a global variable. So over here, we have declared a string called name, and we've initialized it with the value Lisa. And note how it's at the top of the program and it's outside all the functions. So we're going to simply print it inside our main function. Now this proves that a global variable can be accessible from anywhere in a program. Let's understand what are zero values in Golang and why are they useful to know. So in Golang, if you're declaring a new variable, but are not necessarily initializing it with a value, the variable is given a default value. And this value is known as zero value and depends on the data type of the variable. So if the data type of the variable is bool, then the value is false. If the data type of the variable is int, then the value is 0. It's 0.00 for floats, and it's an empty string for strings. For pointers, functions, etc., the value is nil, but we'll look more into that when we would study about those topics. Let us understand the concept of zero values with an example. So we're going to declare an integer first. Notice how it's just a declaration and we have not assigned it any value. So if we're going to print this variable, we get the value 0. Why? Because 0 is the 0 or default value of integer variables. Similarly, we're going to try it out for float. So if we create a float variable and we print it, we get the value 0.00 in the output. Again, because 0.00 is the 0 value of a float variable. Similarly, you can find out 0 values of other data types as well. Now, the fact that Ko makes this design decision is an important point to note when working with variables. In future modules, we will be using this knowledge for use cases like checking if a variable is empty or it's not been initialized and performing some function accordingly. In this module, we would learn how to read input from a user. So one of the most used ways of taking user input is through scanf function, which is provided by the FMT package. So scanf function takes a format string along with a list of variable number of arguments. This string contains custom specifiers that the scanf function uses to format the final output string. The list here is the list of all arguments where you want to store your data. Let us understand this with a few examples. So let's start with our package and import declarations. We declare a variable name, and we would be using this variable to store the input from the user. We then print out a statement for the user so they know they have to enter their name. Next, we use a scanf method to take the input from the user. The format string over here consists of %s, which, if you remember, is a format specifier for string. And the arguments consist of the name variable, which is a string variable itself. Note the ampersand sign over here. We need to use it with the scanf function. We would understand this more when we would be studying about pointers. Let's print a variable to see what happens. When we run the program will prompt the user to enter their name. So if we enter a name, it gets stored in the name variable. So over here, the name variable will now contain the string Priyanka. And we get our output, hey there Priyanka. Let's see how we can take multiple inputs using the scanf method now. So we'll declare two variables, and we would be using both of these variables for storing input from the user. Again, a print statement for users' convenience. Now, to note that you can also take input by writing scanf statement 2 times over here. That is for each input. However, you can also take multiple inputs through single scanf statement this way. We have specified format specifiers for string and bool over here, and then we are storing these values in name and isMuggle variable. So name is a string and isMuggle is a bool kind of variable. The order of format specifiers should match the order in your arguments here. For now, let's just print out the variables. So when the program is run, the user gets a prompt to enter the input. We enter Hermione for our name and false for our isMuggle variable. So here, as you can see, that it reads Hermione and then stores it in the name variable. It then encounters a space, and after the space, it finds the value false and it stores it in the inMuggle variable. So scanf function reads from the input source sequentially. Hence, we must give the list of arguments in the order that's specified in the format string. So the FMT scanf function returns two values. Count, which is the number of arguments that the function writes to successfully, and the error, which is any error that's thrown during the execution of the scanf function. And we'll be using this information to see what errors can be caused while taking input from the user. So let's take an example. Here we declare two variables of type string and int. Then we're going to write a scanf statement to take two inputs, one of string type and another of integer type. Over here, we have written correct format specifiers and we have specified our arguments correctly. But the thing to note here is that messing up with format specifiers or incorrect arguments will also throw you an error. Over here, we print the return values from the scanf function and our two variables. Now, during our input, we pass in a string, but instead of passing an integer, we pass a string again. So it was expecting a string and a number, but we passed two strings instead. We get the following output. Now count is 1 because we stored input successfully in just one argument, and that is a variable a. As you can see, error is expected integer since we were expecting an integer, but it got a string instead. So it gave us an error. The value of variable a is Priyanka and the value of b is 0. The value of b is 0 because it's the 0 value of an integer. So previously we learned how we can create variables and we played around with them. For this videos, we would learn that given a variable, how can you find the data type of that variable? So to check or find the type of variable or object in Go language, we can use the capital T format specifier or the type of function from the reflect package. Let's start with capital T format specifier. So this is the simplest way to find the type of variable in Golang. Here, we're going to declare 4 variables of type integer, string, boolean, and float. We are then going to print the value of the variable and the data type of the variable using the respective format specifiers. So we use %v to print the value of the variable, while %T to print the data type of that variable. And on running the program, we get our expected results. So we get variable grades is equal to 42 and it is of type int. That's right. Then we get that variable message equals to hello world and it is of type string. Is is equals to true and is of type bool, while amount is of type float 32. Now the type of function can be used not just for finding out the data type of the variable, but also for finding the type of simply a value or literal, as we say. First, we would need to import our packages. So fmt for formatting and printing our output, and reflect package for using the type of function. Now here, in each printf statement, we pass in different kind of literal to the type of method. First is an integer, second is a string, then we have 46.0, which is a floating point number, and last is true, which we know is Boolean. Also note how we use %v in this case to print the value that's returned by the type of function. Now let's run the program to see the output. So we get a correct output, that's int, string, float, and bool. Now let's use the type of method with variables. So here we are going to declare 2 variables of type integer and string. And then we are going to print the value and the data types of both of these variables using the type of method. Note how we pass in the variable name to type of method this time. On running the program, we get our output as follows. So variable grades equal to 42 and is of type int. And variable message equals to hello world is of type string. That's right. So in this video, we would learn how we can convert variables from one data type to another. The process of converting one data type to another is known as typecasting. And data types can be converted to other data types, but this does not guarantee that the value of that variable will remain intact. Let us learn how to do typecasting using some examples. Let's start with converting an integer to float. We can do this by simply wrapping the integer around float 64 or float 32. So over here, we have declared an integer I, we declare a floating point number f, and initialize it to contain the value that will be returned after converting I to float. And then we're going to print the variable f. So when we run the program, we get 90.00, which is the converted float value of the integer 90. Converting float to integers. So Go can convert floats to integers, but we end up losing the precision of the float. So we can convert a floating point number to an integer by wrapping the float around int. You can add a floating point number inside of the parenthesis to convert it to an integer. Here, we first declared a floating point number, then we have declared an integer and initialized it with the integer value that will be returned of the f variable. We then print our integer variable. On running this, we get our output as 45. So this conversion has basically truncated all the decimal point of 45.89 and has returned us just the number before the decimal point. Let us learn about the string conversion package. So this package consists of methods that we can use to convert integer to string and vice versa. So the first method is called itoa, and it converts integer to string, and it just returns one value, which is the string formed with a given integer. Let's see how we can use this method. So to convert an integer to string, we would first need to import the string conversion package. Now here, we're going to declare an integer. We're going to create a variable called s, which is of string type, and it's going to be initialized with the value that will be returned by the itoa method of the string conversion package. And then we are simply printing the string. Note how we have passed our integer I to the itoa method. On running the program, we get 42 as our output. The codes around the number 42 signify that the number is no longer an integer, but is a string value. Also, because it's stored in the s variable, which is a string type variable. The next method is a2oi, which converts string to integer, and it returns two values, the corresponding integer and if there's any error. So to convert a string to integer, we would again need to import the string conversion package. Now over here, we're going to declare a string variable. We are then going to store the return values that are returned by the a2i function, and we're going to print those values. So over here, we are printing the value as well as the data type of both the I and the error variable. So over here, when we run the program, we get this output. So since 200 is a pure integer, we did not face any error in converting it to an integer. So we get 200 and int as the value and the data type of the I, while the error and even the data type of the error is nil. Cool. Let's see one more example. So over here, we've declared a string that cannot be converted to an integer, and the a2i function would return us an error for this conversion. So we're going to print the return value and the data type of these values. On running the program, we get 0, int for as the value and the data type of I, while we get the error message and the error data type. So the error data type is a custom data type in the string conversion package. While if you see the error message, it simply says that it's an invalid syntax because we cannot convert 200 ABC to a pure integer. In this module, we would learn about constants. So constants, as the name states, they are variables whose values once initialized cannot be modified. The syntax to declare a constant in Golang is this. So it's initialized by using the const keyword. Then you assign the constant with a name. Then you specify the data type of the constant. So the data type in case of constants is optional to provide. If you do not provide it, it's implicitly inferred by the compiler. Then we have the assignment operator. and then the value or data that you want to store in the constant. So we have two kinds of constants, typed and untyped. Constants are untyped unless they're explicitly given a data type at declaration, and they allow for much more flexibility. An example of how you can declare and initialize an untyped constant is this. So you write const age equals to 12. Note how we did not specify the data type. Again, if you want to specify more than one untyped constant, we can write something like this. Talking about typed constants, these are constants where you explicitly specify the data type in the declaration. But the flexibility that comes with untyped constants is lost here. So to create a constant of string data type, you'll need to write const name string equals to Harry Potter or const age int equals to 12. For a further examples, we would be sticking with untyped constants. So let us understand the concept of how we can declare untyped constants. So we're going to declare and initialize three constants over here, and we're simply going to print its value and data type. So we get our expected results. Now let's come to the core concept of constants. That's once initialized, you cannot change their value. And any attempt to change the value of a constant will cause a runtime panic. So we've created a constant called name, and then we're going to try to change its value. Let's print it and see what happens. So we're going to get an error that says cannot assign to name declared constant. So the compiler is signaling us that you cannot assign or reassign a variable because this is a constant variable. Also, an important point to note here that you cannot declare constant and not initialize it a value and maybe try to assign it a value later on. So you can't do something like this. If you would do this, we'll get an error. And the error is going to say that missing value in constant declaration. So you have to assign and declare constant at the same time. The concept of default or zero values does not apply here. The shorthand variable declaration does not work for constants. So the compiler will give you the following error if we try to use the shorthand variable assignment operator. So it will say unexpected : equal to, because it was expecting the simple equal to or the simple assignment operator. Let's see a use case of where we can use constants. That would be calculating the area of a circle. So we know the value of pi. It is a constant and it's not going to change. So you can simply create a float 64 constant for it. Then we're going to create two variables. We're going to calculate our area and we're going to simply print it. And that's all about variables and constants.